Hello people. Today we shall learn about the polling concept in service package. So many of us confused on the topic of the polling and unable to crack the interview with respect to the polling. Now the interviewer might be expecting some in-depth knowledge about the polling concept. Now in this session we will learn about the polling concepts, why we need to use the polling, what is the important role in the Pega, and why Pega is recommending to use that polling. Everything, all the concepts we will be learning in this session. Let's move ahead. So what is polling? So polling is nothing but what? It's kind of a requester, we can say a requester that are reserved for the use. Okay, if for suppose if we have in any application or else any app, if we have developed any sort of app, then we will be in a controlled manner that how many requesters need to be waited outside, how many requesters that need to be served, and how many requesters that need to be idle. So all these terms will be termed it as a polling. So in the Pega, now the pooling has its important significance. So because for a small app, we might not use this pooling and we might not a greater extent to this pooling. But when comes to the in order to handle the large number of data, large number of users, so then the pooling is an important plays an important role and as well as a vital role as well. We need to handle the app in a such a manner that it won't get any sort of service error or else we can say any sort of discrepancies in the output. So we need to handle that incoming requesters. So we need to segregate, we need to wait for some time, we need to handle a care kind of thing. So let's move ahead and what are the other components we need to learn in the polling concept. Now in this, now we will be having idle requester and active requester as well. So let's I will take you into a scenario. So wherein a couple of in the left side, so you will be having a couple of members, nothing but a couple of passengers are waiting for a bus. So these are nothing but what idle requester I can say. Now coming to the Pega context, now idle requester are currently in the pool but waiting for a request we can say. So that means so they are in the bus stop, and they're waiting for a bus. So whenever any sort of request has come, then it will convert into active. Now comes here active. So active request is nothing but what? They're currently in the bus, I can say. Means they're currently in the service. They're currently in the operation, I can say. So those are nothing but what? Active requesters. So now we come to an conclusion that idle requests is nothing but what? Which are currently in the pool and waiting for a service, waiting for a request, we can say. Wherein for active requesters, now they are out of the pool and they are in the service request, they are in the service, I can say. All right. Now where we can see this idle, active, and as well as max wait. So in the service package, now we will be having a separate tab called pooling. Now over here, now we will be having maximum idle requesters, maximum active requesters, and another term called maximum wait in seconds. Now what are all these things? So why it has been uh, having only 10? So why only Pega recommending 10, or why it is a default 10? Okay, everything we can um learn in the today's session. How it works actually. So first go when we go back to this pooling tab, right? So first of all, we will be having maximum idle requester and maximum active requesters. First suppose, okay, so here we have termed it as a 10, right? Okay, we have set the idle requesters as 10 and as well as active requesters also 10, and also we have set the wait in seconds also 10. That means what are all these things actually? So why we need to put all these things and how it works in the background. So let me take you into scenario. So over here now we have termed it as all of the 10, right? So for suppose you developed an app, okay, and uh, for suppose if the 10 requests has come, okay, all at once at 10 users, nothing but 10 requests has come, hit to your service. Now what happens? Now Pega blindly, it doesn't create any sort of requesters. First it will check whether any idle requesters are present or not. If the idle requesters are present, then it will reuse those requesters and it will be participating in the service now. So whenever those active requesters has been converted, right? Those are from the idle requesters to active requesters. Now when the active requesters has been uh, I can say they when they finish their work, I can say in the broad manner I can say. So then it will come back to its original position, that is nothing but idle requester. So let's take an example like 10 requesters has come into your app. Now what happened? Now first Pega will check whether idle request is present or not. Let us take an example that idle requests are 0. Now what happened? Now the Pega will create 10 requests. Why? Because idle requests are 0. So that's why Pega need to create 10 requests. Why only 10? Why? Because here we have termed it as a 10 maximum active requests. And the requesters has come what? 10. So that's why now we can create 10 requesters all at once. Now Pega will create a 10 requesters. Now it will participating in the service. Now what happens once it finished its work? Next, it will sit back to the idle requesters. Now active requesters is 0 and idle requesters obviously 10. So this is how it works actually. Now let's take another example wherein, for suppose, if the 20 requests has come, now what will happen? So first, already we have a 10 idle requesters. So now Pega need to create how many requesters? Another 10 requesters it will create, isn't it? Now what will happen in this? So first it will utilize the idle requesters, that is nothing but 10. And next remaining how many we need? We needed 10 active requesters. So first it will utilize the idle requesters, and how many are there? So the idle requesters are converted into active requesters. Now the active requesters will be having a 10 once it finish its job, once it's iterate its job, once it complete its job, then it will run the next iteration. So that's how it behaves. For suppose, let's take another example. If the requesters are 50, but here we termed only the active requesters are 10. So in that case, how it behaves now? So already we have a 10 idle requesters and remaining we need 40. So does the Pega creates 40 idle, 40 requesters all at once? Yes, obviously. So first, what it does, first the maximum idle requesters are 10, right? So first it utilizes the 10. Next remaining how many? 30. So that means it will create 30 requesters. So it will goes on actually. So it will goes on, it depends on the maximum active requesters what we have defined over here. So over here now we have defined 10, 10, 10. So that means it must be in the threshold value. So the remaining 30 requests are there, right? So it will segregate in the batch process kind of thing, and then it will work in a pool manner. So first it will complete its job, next it will wait. So that's how it comes. So this is nothing but maximum wait in seconds, I can say. So that means here the default is 10 seconds. So that means first job. So whatever the first job is there, right? So it will wait once it completes its job, right? So for that completion of job, First, it will wait for 10 seconds. For the next iteration job, in order to get into the next iteration job, it need to wait for 10 seconds. And next, it will participate in the active requesters. That means the processes. And next, it comes in the idle requesters. So that's how it means actually. So once it completes everything, then it comes into the idle requesters. Why? Because when the active requesters are obviously zero, then all the requesters must be in the idle requesters. So that's how it behaves. So over here, one thing we need to understand that Pega blindly don't create any sort of requesters. First, it will check whether the ideal requesters are present or not. If it is present, then it will reuse. If it is not present, based on the threshold value we have presented over here, it will create and it will participate in that session. So based on the iteration, based on the batch job, based on that batch, right? So it will wait. So whatever the maximum wait in seconds we have provided over here, so until it will wait until the threshold time meets, then it will participate in the next job. So that's how it works. So how it works? So that's what. Very first time a service from the service package runs, uh, a request is created for it along with the, see here. So that's why we have termed it as a first time I said. Okay, first time. So first time what will happen? Obviously a requester is created. And next, when the service processing complete, the request is added to the pool. So that's how. And for the next time, for the next time, obviously we have already this requester whatever it may be, right? So it has been already added in the idle requester. That's how it will automatically it will reuse that, and otherwise a new requester will be created. So based on that actually, based on the we can say that scenario, okay, and based on the number of requester sessions outcoming, incoming from the outside. That's how it behaves. And what is maximum ideal requesters? Maximum ideal requesters obviously we will be having. So maximum ideal requesters are setting that defines the size of the pool, I can say. So for suppose, so as I said right in the starting of the slide, so ideal request nothing but it doesn't have any sort of work first of all. They're simply sitting. They are waiting for the request. That's it. And they are in the pool. They are waiting for the service. That's it. Okay. And here one thing we need to observe, if we want to allow the maximum ideal requester, then we need to term the -1. That's it. If we allow -1, that is nothing but what? A maximum ideal requesters will become. So there are no limited, infinite we can say. So that is nothing but -1. So these are comes under a maximum ideal requester. The same carries for the active, but the only difference is here the ideal requesters are waiting for the service request, and over here active request nothing but what? They are already in the service. They're already in the job, and the -1 remains the same. And if a requester pooling is disabled, then we can set the maximum requesters to 1 actually. That is based on the scenario. So that's how the difference between active and as well as a we can say idle. So that's why I intentionally created a scenario like a couple of passengers are waiting at the bus stop. So bus stop is nothing but what? Pool. They are in the pool. They are at the pool actually. They are waiting for the service. They are waiting for the bus. So active requires nothing but what? They are already in the bus actually. So that's how it there. So once they completed journey, now what will happen? They will be in the rest position. Nothing but they are in the idle requester. So that's how it behaves. Okay. So in this scenario, everything. So one thing we can strongly say that Pega didn't create any sort of requesters ideally, I can say blindly, but they are reusing. So that's how the importance of the pooling is. The main significant role of the pooling in the Pega is reuse. And in the coming slides, I will be explaining about the other significant roles as well. So that's why pooling plays a vital role in the service package. and obviously maximum wait. So as I iterated, so maximum wait is nothing but what? How long the system need to wait for a system in order to return to the pool. So based on what we have defined in the maximum wait, so as per that, it will implement. If for suppose, if the time interval passes before any requester returns to the pool, respective pool, now what happens? Obviously, the system will fail. Now, a failure message will be sent to the external client message, external client system, like uh, system runtime. We can say, timeout session, kind of thing. Okay, in our daily life, we will be seeing all this messaging, right? So that's how it behaves. So that's what it is having that maximum weight. So this also plays a vital role in the pooling tab. So first of all, we need to understand what is maximum weight. So then only we can say define the maximum accurate maximum weight, actually not accurate but up to that mark. So we need to handle those requesters, those bulk requesters. In real time, we will be having a for suppose if you are developed an app and we need to handle many requesters, right? Obviously, for suppose if we have an example like in the weekends or else in the daily, the traffic police challan wala. Okay, so we will be having a many traffic police. Obviously, they will be having a machine, they will be having an app, so that controls what that uh, you know that marks the challans as well, right? So what will happen? So it will having a server. Now the server need to be handled in a significant way, okay, in an optimized way. So that's how actually. So all at once, for suppose 1 lakh requesters are hit to the server. Now obviously what will happen? The server will crash. Obviously it will crash. Okay. So that's why in order to limit all these things, so we need to define maximum idle, active, and as well as maximum wait in seconds. And why we need all these things? So that's what. So requester pooling SWOT improves the performance, and also the main thing, reuse functionality, and it will shares the allocated resource. So and as well it will eliminate the service wait time. So these are all the important aspects and advantages if we use that pooling. And how we can clear the requester pool? So we have created a requester, we have defined a variable idle, active, and as well as wait time as well. Okay, we have created, that's fine. In the background, it does its job. But how can I clear those requester pools now? Do I need to handle it manually or how? So for that, we will be having an admin studio. In that admin studio, now we will be having a requester pool. So if you just click on the requester pool, now for each, see here, for each requester pool, for each node, okay, here we will be having a selection of all nodes or specific node. If we just select all nodes, right, so the respective nodes, okay, the respective pools will be listed over here. Now you can click on the three dots. Now you can clear the requester pool. Okay, so when you just hover on the clear requester pool, right, now the Pega suggesting that clearing of requester pool plays a vital role in the improving of the performance. So this is all about the requester pool. Hope you get the great idea on the requester pool, and while you will be in an interview or something, right, you need to cover all these topics, like what are the what is first of all pooling, what are the types, I mean what are the available we can say in the polling tab, and what happened if we didn't mention any sort of active idle, and as well as this requested time, requested time in seconds, and why we need to use the pooling, and what happens if we keep -1, and what happens if we keeps uh, I know nothing or whatever it may be default. and why we need to clear all these things and where we can clear these request poolings as well. So these are all the concepts. If anybody asks about what do you know about the pooling in the service package, then we need to cover all these topics. So then the opposite person or else interviewer might be impressing. So this is all about the requester pooling. So hope you understood this concept, and it's time to share your love yourself. Please, if you like our session, so please subscribe, like, comment, and as well as share. And many thanks for your time and as well as for your patience. Thank you very much. Take care and bye bye.